Hello everyone and welcome to today's video. We keep on getting many queries around PMP questions and today we thought we are going to share with you one such question and how to solve it. Most of the questions that I have received in the recent past have been around network diagrams and critical path. So both of these topics seem to be a bit confusing to the candidates and aspirants, and that is why I thought let me present to you today one such question from the PMP question database. So the question is about calculating the critical path, and for that we have to create a schedule network diagram first. Let me share with you my screen so that you can see what is the question and how to solve it. So as you can see, the question is asking you to calculate the critical path using this particular network diagram. And it gives you various options 1, 2, 3, 4. Now to calculate the critical path, you need to first create the network diagram. So we have various activities and the durations as well as the predecessor information available to us. So let's get started with solving this. Now, to ensure that this video does not get stretched beyond a certain length, I have already kept some of the information ready. All right. Now, what I have done is basically I have picked up this particular table and created individual activities using rectangular boxes. And I have also assigned or marked the duration below them in red. On the top right corner of the box, what I have done is I have marked the predecessors in blue color so that it becomes easier for us to create the network diagram. Now with this information, let us quickly create the network diagram. So first of all, A, B, and C, these three do not have any predecessor activity, which means there is no activity which is starting before these three. So let us just pull these three up directly and paste it here just for the ease of creating the network diagram. I'm just using MS Paint, but during the examination, you would be expected to, create this using your pen and paper, right? Then the activity D has a predecessor as activity A. So I'm going to take this and paste it here in front of A. Then activity E and F have predecessors as activity B and C, which means again they are going to come in sequence right after these two activities. All right. Then what is the next activity? Activity G has a predecessor of D and E. So D and E leads to activity G. So let me pull it here. And then finally, activity H has a predecessor in F as well as G. So let me put it a bit forward. All right. So if we start creating, start creating the flow using arrows, this is how it is going to look like, right? And then from activity B, activity G is having the predecessor in activity D and E. So these two activities put together will lead to activity G. And then H has a predecessor in activity F and activity G, right? So this is how our network diagram will look like. Now, now the question asks us to create or rather calculate the critical path. Now, what is the critical path? Critical path. All right. Critical path. Critical path. It is called as the longest path which will require the shortest amount of time for the project to be completed, right? Critical path is the longest path, right? Which is going to take the shortest amount of time for the project to be completed. Now, this might look contradictory, but if you look at it logically, it will make sense, because if we do not take the longest path, in that case, it is not going to be long enough for the project to be completed. So this is the bare minimum that the project will require to be completed. All right. So here, let us first look at the longest path. Which particular path is going to be the longest here? So here, activity, the first path is going to be, let me use the color green. So the first path is A to D to G to H, okay, which is going to require 2 plus 1 plus 7 plus 2. All right. So this is going to require how much time? 2 plus 1 is 3 plus 7 is 10 plus 2 is 12. All right. The next one is B to E to G to H. So it is going to require 4 plus 6 plus 7 plus 2. All right. Which is going to be how much? 4 plus 6 is 10, 10 plus 17 plus 2, 19. Next one is C to F to H, right? C to H. This is going to require 3 plus 5 plus 2 is equal to 10. All right. Up until now, this is fine. We are able to calculate. Now, if we go back, if we scroll back and look at the question, do we have these options here? A, B, F, G. Okay, which one is A, B, F, G in the network flow? A and then B and then F and G. So basically, these do not have any connections, right? A, B, F, G. That is not going to be the right option for us, right? Because critical paths is supposed to be connected to each other. The next option is D, F, G. D is not linked with F. D is linked with G, but it is not linked with F. So even that is not going to be the right option. After that, we have B, E, G, H. Now B is linked to E, yes. E is linked to G, yes. G is linked to H, yes. So this might be a feasible option. Next one is B, F, H. B is not linked to F, and F is linked to H, but B is not linked to F. So again, this is not going to be the right option. So here in this particular case, we can very clearly see from the options itself, after creating the network diagram, that BEGH is going to be the right choice. But when we were calculating our critical path, we have also seen that BEGH is the longest path. That is, total of 19 days is required for this project to be completed, for all the activities of this project to be completed put together. This is where it is called as the shortest time. CFH is the smallest number, but if the project is supposed to end on the 10th day, in that case, let's say B and C, B and E put together is 10. That means the activities G and H will be left incomplete. So the project cannot be completed per se, right? For ADGH as well, for this particular path as well, 2 plus 1, 3 plus 7, 10. So this is where on the 10th day, if we are considering on the 10th day, the project is going to complete, then H is again going to be left incomplete on this particular network diagram. So this is how we can ascertain that the longest time, the longest path is actually the shortest amount of time to complete the project. Okay, So that is how this particular option becomes the critical path for us. So this is how you create your network diagram based on the question, based on the information that is provided to you, and from there you try to identify the critical path. And after identifying your critical path, this is how you essentially try to validate whether your calculation is correct or not logically. Having said that, I hope you enjoyed this video today and you learned a bit more about critical path and how to create a network diagrams. We will meet in the next video with more such questions and queries to help PMP aspirants. Thank you and have a good day.